So we are dealing with problem number 2.8 in this series, and the problem is asking, find the pressure of the air in a vessel being evacuated as a function of evacuation time T. The vessel of volume is capital V, the initial pressure is P naught. The process is assumed to be isothermal and the evacuation rate equals C and independent of pressure. So in case you haven't watched 2.7, then kindly watch 2.7 as we have discussed how exactly an air pump works. So I'll try to explain it again. Let us begin by drawing a diagrammatic situation. So this is how we are again demonstrating a valve piston arrangement which is referred as a pump. So over here the question is suggesting the process is assumed to be isothermal and the evacuation rate is equal to C. So we can say that initially the volume is V, and in a time T or 1 second this C increase in the volume, which is the rate of evacuation. We are considering C into dt as the increase in the volume as the piston slide towards the right. So as the piston slide towards the right, the gas from the chamber is going to fill inside this piston, opening this valve, and then this valve is closed and this gas is released. Again the piston will slide towards the left, and then again the valve will open as the piston will slide towards the right, and then the gas will be ejected. So over here initially the pressure is P naught, volume is V, and the rate of evacuation is equal to C. So we can say that initially, if at a certain instant of time the pressure is P and volume is V, and since the process is isothermal, the product PV is going to be constant. So after a process or a time dt, if the pressure becomes P plus dV, then the volume will definitely becomes V minus C dt, where dt is the rate of evacuation of the gas which is mentioned in the problem. So over here we need to deal with this expression to get the desired solution for the problem. So we get PV equals PV minus PC dt plus VdP minus C dP into dt. So now this term dP into dt will be too negligible, so we'll omit that part. P dV on either side will cancel out, and then we can write over here that V dP is equal to minus P C dt, and therefore we write over here dP by P is equal to minus C by V dt, and then integrating both side. So as we are integrating both side, we say that initially at T equals 0 the pressure is equal to P naught, and after a time T the pressure will drop to a certain value, say P, and therefore over here on solving we obtain ln P by P naught is equal to minus C by V into T, and over here we can write that pressure P is equal to P naught e to the power minus Ct by V. So over here the negative sign is implying that the pressure is decreasing with time. So the pressure P is going to decrease with time. It is also evident from the part that as the gas is getting ejected from the chamber and the ejection is isothermal in nature, so pressure will eventually drop, and the pressure drop will be of exponential type. So need to keep a note on this. This is the answer to this problem. In case the problem is repeated, you just need to remember this, and if it is asked in a graphical form, you can simply draw an exponential decay graph for the drop in pressure if the rate of evacuation is equal to C.